Welcome. All right, so now we're going to graph one in standard form. All right, determine whether the graph opens upward or downward. All right, so the graph, oh, there we go. Always takes a little while to start when I record. It's like the pen doesn't want to work. All right, opens upward because A is greater than 0. It's positive, right? Let's actually write down A, B, and C. Might be helpful as we graph this one. All right, so A is 4, B is 4, and C is 1. Find the axis of symmetry. All right, so, and of course it's also the value of H in the vertex. So it's going to be negative 4 divided by 2 times 4. So this is negative 4/8 or negative 1/2. Now we can plug negative 1/2 back into the function, or we can decide to use the formula for k. Either way, we're going to get the y-coordinate for the vertex. Because it's a fraction, let's go ahead and just use the formula. All right, so k, as a reminder, is negative, all negative, b squared minus 4ac divided by 4a. So k is negative 4 squared minus 4 times a is 4 times 1, all divided by 4 times a is 4. Oh boy, that's a lot of 4s, isn't it? We are missing a parentheses there. All right, I think I have, yeah, all the right number of parentheses. And let's go ahead and simplify that. So negative 16 minus 16 divided by 16. Well, that is 16 minus 16 is 0. So really doesn't matter about the denominator. It is 0. So the vertex is the point negative 1/2, 0. All right, so we have the vertex. Let's go ahead and find the y-intercept. All right, so we can either plug in 0 for x, or we can look at c, because they're going to be the same thing. Because if we plug in 0 for x, the only thing left is the c. So g of 0, the y-intercept is 1. So we have the point 1, 0. Right, so we've got 2 points so far. The vertex, negative 1/2, and the y-intercept, 1, 0. All right, let's go ahead on the next page and find the x-intercepts. All right, now, if you weren't sure if this was factorable, you could always take b squared minus 4ac, which is the discriminant. And if you do that, all right, so b is 4. So 4 squared minus 4 times 4 times 1. All right, well, that is 16 minus 16 is 0. And 0 is a perfect square. So it is definitely factorable. And actually, that 0 tells us something special about our x-intercepts. But let's just go ahead and factor, and then we'll talk about what that 0 tells us. So I'm going to put the 0 at the end. 4x squared plus 4x plus 1 equals 0. 4 times 1 is 4. Oops. And actually, instead of squeezing it in there, I'm going to put it over here. I don't have anything else over here. Two numbers that multiply to give us 4, but add to give us the b term of 4. Well, that's 2 and 2. So 4x squared plus 2x plus 2x plus 1 equals 0. First to our group, second to our group, we'll pull out the 2x. We have 2x plus 1, right? They both have an x, so x has to be part of the greatest common factor, and they are both divisible by 2. And that is the greatest common factor for that one. For 2x and 1, it's just going to be a 1. They don't have any other factors in common. The repeating 2x plus 1 is one factor. The leftover 2x plus 1 is the other factor. And so what the 0 discriminant tells you, it tells you not only is this factorable, but it's only going to have one solution because we're going to have one repeated solution. So our two solutions are the exact same thing. 2x plus 1 equals 0. Subtract 1 from both sides. You have 2x is negative 1. And then divide by 2. X is negative 1/2. So you have, so the x-intercept is negative 1/2, 0. And this is called multiplicity 2. What multiplicity 2 means that it appears twice. Now, when we get to graphing polynomial functions, we'll talk a lot more about multiplicity because that happens more often when you have more x-intercepts. But this is one that has the same x-intercept twice. And when a x-intercept appears twice, rather than crossing the x-axis, it's going to do what's called touch and turn. So negative 1/2, 0. Gee, where have we heard that point? Where have we had that value before? It sounds familiar. Oh, yeah, it is also the vertex. So our x-intercept is also the vertex. So we've got 2 points, the x-intercept and the vertex. So we are going to come up with another point for our graph here. I already have the axis of symmetry graphed. This is x equals negative 1/2. That was the axis of symmetry. The vertex is negative 1/2, 0. The x-intercept was also negative 1/2, 0. The y-intercept is 0, 1. The domain is all real numbers, always for a quadratic, and actually any polynomial. Any time we have x raised to a power, there's no number I can't raise to a power. And the range is going to go, as both ends are up, right? So it's going to head to infinity. The starting value is going to be the y value, the y coordinate of the vertex. So 0 to infinity. And let's go ahead, before we graph it, let's go ahead and do that. Actually, no, we'll put the increasing, decreasing after we graph it. So let's go ahead and graph our points. We have negative 1/2, 0, which is right here. And we have 0, 1. And then we have this point over here we can get using symmetry. All right, so this point here is 0, 1, and this point over here is negative 1, 0. So if I have a point 1/2 to the right, I have a point 1/2 to the left. And that is really, really small, right? I mean, most of you, when you draw your graph, you make like 2 straight lines, like it's going to be, you know, 2 horizontal lines with a little curve at the end. And in reality, the parabola keeps getting wider. Right? It's not going to be a horizontal line. So let's go ahead and find another point so we don't draw our parabola probably way too skinny. And so here is how you can find your, let's call it a bonus point. And we talked about this a little bit on another graph, but our bonus point only ended up taking us up 1/2 because our A was pretty small. So I am going to write this nice and concisely for you, and I think easy for you to apply. So, and actually, these are bonus points. We have a right bonus point, and the right bonus point is going to be h plus 1, and the k is going to be plus a. That's the one to the right, and the one to the left is going to be h minus 1, so we're going to go to the left, and still k plus a. And that works whether a is positive or negative. So if your graph is concave down, a will be negative, so you'll be adding a negative number, meaning you'll go down. Now this only gets you one more point because the rate of change is not constant in a parabola. It is not a line, right? The rate of change will keep increasing. But for right from the vertex, you can get one more point to the right and left doing this. All right, so let's actually calculate it out. And it's actually easier even than plugging in a value. So easy. All right, so here is our right bonus point. All right, our h is negative 1/2 plus 1. Our k is 0, and a is 4. So that very first time when we increase 1 to the right, we're going to go up 4. And when we increase 1 to the left, actually let's write down the value as a point, we're going to increase 4. So this is 1/2 4. And then our left bonus point is negative 1/2 minus 1, 0 plus 4, because it's symmetric. And actually, even if you didn't calculate it out, if there's a point to the right, there's got to be a point to the left, the same height. So this is negative 3/2, 4. So let's go ahead and graph those two little bonus points for our parabola here, so it's not quite so skinny. So if I go half a point from the vertex, I'm going to be at a half, right? Or excuse me, I move one from the vertex, I'm going to be at a half. And then I'm going to count up 4. So here's the point, 1/2 4. 1, 2, 3, 4. Right here. That is a point on our parabola. And then 1 to the left, so that's going to be negative 1.5. And up 4 again, 1, 2, 3, 4. There's our other bonus point. So in addition to the 3 we had graphed, we also get 1/2 4 and negative 1/2 4. And this works all the time. All right, that very first point, if I go 1 to the right or 1 to the left, I am going to go up exactly the same value as A is. All right. So different than our 0, 1 and negative 1, 0 here, because I only went up a half. Right? But that still is, those are 2 points that we had. So now we, instead of just having 2 points or 3 points, we have 5 points. And we'll make probably a better parabola. This does not a vertical line. It does go out. Connect your points. And there you go. And I'm a little crooked on top. But other than that, it looks pretty good. All right, so it is going to keep getting wider. I know we have a tendency to go, try not to go too vertical. Try to make it look like it's a little bit going out. All right, that looks pretty good. Let's go ahead and do the last things, which is the increasing, decreasing, and behavior. I'll write over here. So it is, graph is increasing from the vertex, which is negative 1/2 to infinity. The graph is decreasing from negative infinity to negative 1/2. And then the end behavior, I'm going to write over here. Hopefully you can read it. F of x, both ends are up in the air like he just doesn't care. F of x approaches infinity as x approaches negative infinity, and f of x approaches infinity as x approaches infinity. And there we go. That's it. We finished. And how long did that take us? Not too bad. I thought it would take 10 minutes. It took us 15, but we did a lot of talking. All right, so thanks for watching, and I hope our bonus points to the right and left make perfect sense to you now. All right, and so that's just one way that you can get one extra set of points. Very helpful sometimes in graphing, especially when you only had a vertex and a y-intercept. All right, thanks for watching. Bye for now.